Electrical bonding is crucial for electrical safety, especially in outdoor environments where moisture and potential hazards exist. Bonding establishes a low-resistance path for electrical current to flow, ensuring that any stray currents or shorts are safely redirected to the ground. This prevents electrical shocks and potential hazards. According to the National Electrical Code, all electrical equipment and metal components associated with a spot hub must be bonded together. This includes, firstly, the spot hub shell, secondly, the pump, thirdly, the heater, fourthly, the controls, and fifthly, the gas supply pipe. The bonding wire used should be bare or insulated copper wire with a minimum size of number 8 American wire gauge. All bonding connections should be made with listed bonding clamps or connectors and should be securely fastened. In your case, the following bonding should be implemented: 1. Attach one end of the number 8 bonding wire to the stainless steel tub. 2. Run the bonding wire to the equipment room. 3. Connect the other end of the bonding wire to a bonding busbar or grounding lug located on the metal frame of the gas heater. 4. Bond the pump, control box, and gas supply pipe to the bonding busbar using additional number 8 bonding wires. Once the bonding is complete, it is essential to verify its continuity using an ohmmeter. The resistance between any two bonded components should be less than 0.1 ohms. Bonding is a critical safety measure that should not be overlooked. By ensuring that all metal components associated with your spot hub are properly bonded, you can minimize the risk of electrical shocks and protect both people and property. It is imperative to communicate the importance of bonding to your spot installer and ensure they follow the recommended guidelines for a safe and code-compliant installation. Electrical safety is paramount, and proper bonding plays a vital role in achieving it. The purpose of bonding is to create an equipotential plane, meaning that all metallic parts are at the same electrical potential. This minimizes the risk of electric shock, as there is no potential difference to drive current through a person's body. In the event of a fault, such as a short circuit, the bonding system provides a low impedance path for fault current to flow back to the source. This allows the circuit breaker to trip quickly, disconnecting the power and preventing a dangerous buildup of voltage on metal parts. The National Electrical Code provides specific requirements for bonding spot hubs and other electrical equipment. These requirements are designed to ensure that the bonding system is effective in protecting against electrical hazards. It is important to follow these requirements carefully to ensure a safe installation. The bonding wire must be of adequate size to carry the fault current. Number 8 American wire gauge copper wire is the minimum size allowed by the National Electrical Code for bonding spot hubs. The bonding wire must be continuous and unbroken. It should not be spliced or cut. All connections must be made with listed bonding connectors. These connectors are designed to provide a low resistance connection that will not loosen over time. The bonding system must be connected to a grounding electrode system. The system provides a path for fault current to flow to ground. The grounding electrode system typically consists of a ground rod or a metal water pipe. Once the bonding system is installed, it is important to test it to ensure that it is working properly. An ohmmeter can be used to measure the resistance between different parts of the bonding system. The resistance should be less than 0.1 ohms. If the resistance is higher than 0.1 ohms, there may be a problem with the bonding system. The problem should be corrected before the spot hub is used. Bonding is a critical safety measure that should not be overlooked. By following the recommendations outlined, you can ensure that your spot hub is properly bonded and that you are protected from electrical hazards. Always consult with a qualified electrician if you have any questions about bonding or electrical safety. Remember that gas piping must be bonded as well. This is because gas piping can become energized if it comes into contact with an electrical fault. Bonding the gas piping to the electrical grounding system ensures that it is at the same potential as other metal pots, reducing the risk of electric shock. The National Electrical Code requires that all metal gas piping systems be bonded to the electrical grounding system. This requirement applies to both new and existing installations. The bonding connection must be made as close as practicable to the point where the gas piping enters the building. The bonding conductor must be sized according to the National Electrical Code Table 250.102. The bonding conductor must be connected to the gas piping with a listed bonding clamp or fitting. The bonding connection must be accessible for inspection and testing. Once the bonding connection is made, it is important to test it to ensure that it is working properly. An ohmmeter can be used to measure the resistance between the gas piping and the electrical grounding system. The resistance should be less than 0.1 ohms. If the resistance is higher than 0.1 ohms, there may be a problem with the bonding connection. The problem should be corrected before the gas piping is used. Bonding is a critical safety measure that should not be overlooked. By following the recommendations outlined, you can ensure that your gas piping is properly bonded and that you are protected from electrical hazards. In addition to the specific requirements for bonding spot hubs and gas piping, there are some general bonding requirements that apply to all electrical equipment. All metal enclosures for electrical equipment must be bonded to the electrical grounding system. This includes enclosures for circuit breakers, transformers, and other electrical devices. The bonding connection must be made with a listed bonding connector. The bonding connection must be accessible for inspection and testing. All metal parts of electrical equipment that are likely to become energized must be bonded to the electrical grounding system. This includes metal handles, knobs, and other exposed metal parts. The bonding connection must be made with a listed bonding connector. The bonding connection must be accessible for inspection and testing. The electrical grounding system must be properly installed and maintained. The grounding electrode system must be connected to the earth with a grounding electrode. The grounding electrode must be made of copper or other approved material. The grounding electrode must be buried in the earth to a depth of at least 8 feet. The electrical grounding system must be inspected and tested regularly to ensure that it is working properly. A ground fault circuit interrupter, commonly referred to as a ground fault circuit interrupter, is a device that protects people from electrical shock. It works by monitoring the current flowing through a circuit. If the current flowing out of the circuit is different from the current flowing back in, the ground fault circuit interrupter will trip the circuit breaker, cutting off the power. Ground fault circuit interrupters are required in all wet locations, such as bathrooms, kitchens, and outdoor areas. They are also required in any location where there is a risk of electrical shock, such as construction sites and industrial facilities. Ground fault circuit interrupters are available in 2 types. Firstly, receptacle-type ground fault circuit interrupters are installed in place of a standard electrical outlet. Secondly, circuit breaker-type ground fault circuit interrupters are installed in the electrical panel. Ground fault circuit interrupters are an important safety device that can protect people from electrical shock. It is important to install ground fault circuit interrupters in all required locations and to test them regularly to ensure that they are working properly. To test a ground fault circuit interrupter, simply press the test button. The ground fault circuit interrupter should trip, cutting off the power to the circuit. If the ground fault circuit interrupter does not trip, it is not working properly and should be replaced. Electrical safety is important, and ground fault circuit interrupters are an important part of electrical safety. Be sure to install ground fault circuit interrupters in all required locations and to test them regularly to ensure that they are working properly. Proper grounding and bonding are essential components of a safe electrical system, particularly in environments like those surrounding spot hubs. These measures work together to minimize the risk of electrical shock and ensure the safe operation of electrical equipment. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. This prevents dangerous voltage buildup on metal parts that could pose a shock hazard. Bonding connects all metal parts together to create an equipotential plane, meaning that all metal parts are at the same electrical potential. This eliminates the potential difference that could drive current through a person's body in the event of a fault. The combination of grounding and bonding provides a comprehensive safety system that protects against electrical shock. Grounding and bonding must be properly installed and maintained to be effective. Grounding electrodes must be of the correct type and size, and they must be properly connected to the grounding system. Bonding conductors must be of the correct size and material, and they must be securely connected to all metal parts. The grounding and bonding system must be inspected and tested regularly to ensure that it is working properly. Any problems with the grounding and bonding system must be corrected immediately. Electrical safety is everyone's responsibility. By understanding the importance of grounding and bonding and by taking steps to ensure that these systems are properly installed and maintained, you can help to protect yourself and others from electrical shock. Remember to always consult with a qualified electrician for any electrical work. The electrician will be able to assess the situation and recommend the appropriate grounding and bonding solutions. Additionally, regular inspections of your electrical system can identify potential problems before they become safety hazards. Look for signs of damaged wiring, loose connections, and corroded components. If you notice any of these problems, contact a qualified electrician to have them repaired. Grounding and bonding are not just about safety, they also help to protect your electrical equipment from damage. Surges and other electrical disturbances can damage sensitive electronic equipment. A properly grounded and bonded system can help to divert these surges away from your equipment, protecting it from damage. Investing in proper grounding and bonding is a wise decision that can save you money in the long run. By protecting your electrical equipment from damage, you can avoid costly repairs and replacements. Moreover, the peace of mind that comes with knowing that your electrical system is safe and reliable is priceless. Therefore, prioritize electrical safety and ensure that your spot hub and all other electrical equipment are properly grounded and bonded. This will create a safer environment for you, your family, and anyone who uses the spot hub. Ignoring grounding and bonding can have serious consequences, including electrical shock, injury, and even death. Don't take the risk. Make sure your electrical system is up to code and that all grounding and bonding requirements are met. And always remember, when it comes to electricity, safety should always be your top priority. This extends not just to spas, but also to all electrical appliances and installations around your home. Taking simple precautions, such as using ground fault circuit interrupters in wet locations and avoiding overloading circuits, can significantly reduce the risk of electrical accidents. Educate yourself and your family about electrical safety. The more you know about electricity, the better equipped you will be to prevent accidents and stay safe. With the proliferation of electronic devices in modern homes, it's more important than ever to be aware of electrical safety. From smartphones and tablets to computers and gaming consoles, these devices all rely on electricity to function. It's essential to use these devices safely and to follow all manufacturers' instructions. Avoid using damaged or frayed power cords and never overload electrical outlets. Overloading outlets can cause them to overheat and potentially start a fire. Also, be cautious when using extension cords. Extension cords should only be used temporarily and should never be used as a permanent wiring solution. Choose extension cords that are rated for the amount of power that will be drawn by the devices connected to them. In addition to these general electrical safety tips, there are also some specific precautions that should be taken when working with electricity. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools to avoid contact with live wires. And never work on electrical systems when you are wet or standing in water. Water is an excellent conductor of electricity, and contact with water can significantly increase the risk of electrical shock. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. Electricians have the training and experience to perform electrical work safely and correctly. They can also identify potential problems that you might miss and ensure that your electrical system is up to code. Ultimately, electrical safety is a shared responsibility. By being aware of the risks and by taking the necessary precautions, we can all help to prevent electrical accidents and create a safer environment for ourselves and others.